All right. So today, we're going to talk about testing in React. We're going to do a bit of talking, but then we're going to see how to use this pretty cool framework called Cypress for end-to-end testing. So we're going to talk about why testing is important, the three kinds of tests, end-to-end versus integration versus unit tests, what should I test, a little bit about test-driven development, and a very brief sort of tour of some testing frameworks. When we get into Cypress, I'm going to talk a little bit about what it is because it's actually pretty interesting and does some interesting stuff. We're going to see how to install it, set it up, configure it, add some NPM scripts, see how to run it as there's a couple steps, nothing crazy, but just a couple sort of hoops to jump through. And then we'll write a couple tests. And I was thinking we would write some tests against the to-do app that we worked on yesterday. Any questions before we dive on in? All right. I'm going to ask for a little bit of volunteers for reading in the first part of this in just a minute, just so there's a voice other than my voice in the mix. Um, so there was a question just now about how to prepare for interviews. And one piece of the puzzle here is kind of understanding what matters for professional software engineering. And the context here is, let's say we're front-end engineers at Amazon, and I've added a new feature. Let's go to Amazon.com, in fact. Let's say maybe this like category dropdown didn't exist before, right? And this is this awesome feature that we've added. So now that I've added this feature, since Amazon makes probably, I don't know, $1 million a minute. Yeah. So they make about $1.3 million a minute from Amazon.com. So in that context, just, forget the technical complexity of this feature. I could just be changing the text that says search Amazon in the background here, and I still have to make sure that I don't break this $1.3 million a minute machine, right? And as software engineers, and this is, people will argue if there's a distinction between a software engineer and a programmer or whatever. And there's a lot of good arguments to both sides. I think this is one of the arguments. A software engineer's job is to know how to write code and add it to a running live application in production that's delivering business value, like this $1.3 million a minute money machine called Amazon.com, and be able to guarantee that it won't break. Right. And so that's what tests are for. That and that's what this all these sort of code review processes that you guys are practicing in your team stand-ups and code demos are for, that like my code is reviewed by other people. We have a test suite that it's run against before the change of adding this drop down, or even the change of changing the color of the search bar is deployed. Um, Even the small visual elements, like if I click in here, notice how this becomes orange and everything else is grayed out. Um, Notice how this stuff gets highlighted. A lot of these nicer UI elements are for a good user experience, but a lot of UX stuff is also designed to get people to spend money. And companies run what's called A/B experiments, where maybe like they change the color, the degree of shading a different amount for like 0.5% of all users, or maybe they try a different button logo for 0.5% of all users, and they see if the people with the different button logos spend more money, right? They run A/B experiments all the time. So, even like the visual layout of stuff has a business impact. So testing is about software quality, both so that we can guarantee reliability for the business or whomever our stakeholders are that we're building software for, and also, for our own sanity. It also makes it way easier to refactor code. If I'm changing code that already exists, whether it's adding a new feature or refactoring an existing feature so that it works the same way, but that I'm making the code more efficient, maybe, because refactoring means you don't change the functionality, but you change how it works under the hood. A test is great because it can sort of be a harness, and if I make a mistake that breaks something, I'll find out because the test tells me. So that's a little bit of the big picture of why testing matters in software engineering. And again, this is good to start building that mindset because when you're going into interviews, that's what people are looking for to know that, all right, I understand the value of tests and why it's important. And maybe for my personal project, after graduation, I even wrote a couple tests, right? Tests are not inherently exciting until you've had the pain of dealing with software that doesn't have a test suite. But it's a great example of a real world engineering concern. And I just want to pause and see if folks are curious about anything with this sort of like bigger picture conversation about testing before we dive a bit more into Cypress. Carlos, yes, sir.
So, I guess you can't really see on average because applications do vary a lot, but how big would you say typical test suites are? Like, are you talking just maybe 100 tests, or are you talking, 10 tests per different click you can make on the site?
Yeah, it's a great question. And it touches on a great point, which is tests take time and effort to create, and then they have to be maintained. Front-end tests especially can be brittle if it depends on like a particular CSS class or something like that. Um, and the bigger your application gets, the more thoughtful you have to be about your testing strategy. Like what parts of my application are really important to test, what kinds of tests, uh, what kinds of tests matter more and are higher value in terms of time and effort, what kind of tests matter less. Um, so there's not a one size fits all answer, but the short answer would be a lot. Let's go to React. Um, let's see. We might have to poke around because they have so many packages. Um,
Just React?
no, no, I was thinking the React library itself to see how many tests are in here. Um, let's see. So this is a React package for testing DOM events. So this one might not be the best because it has tests. We would be end up looking at tests for tests. Here we go. This is probably a good one. React DOM. So this is the package that interacts with the browser DOM and renders React into HTML or DOM elements. Let's see how many tests are here. So this is a lot of tests, right? And if we look at this one test, now React is a pretty massive library. So this is maybe not the perfect example for like making a front end web app, but to give you a sense of the amount of effort that goes into testing. Um, at the startups I was at, pretty much every feature I wrote like had to have tests. You had to write tests for it. I wonder if
Well, it makes sense though, right? Because even though it's a lot of up, upfront work, once you have them set up, as long as nothing major is changing, you can just run the tests and know if something broke in the changes you make to the main program, right?
Yes, with a massive asterisk. One would like to think that there aren't a lot of major changes that need to happen with tests. The reality is tests break all the time.
So do you
Software,
have tests of tests?
no, you just have to improve the test. Um, it does raise a good point, though. There's a lot of things tests can't test. For one thing, a test can't test for what we don't write a test to catch. So, like when you talk about software quality, um, I think there's a couple different factors, and I'll just make a notes section here real quick. So, software quality, let's call it coding best practices, um, language and technology choices, uh, code review processes, um, developer tooling, right? Having linters and stuff in my editor that help me catch errors, and testing, and then QA, which is someone doing manual testing in essence, which depending on your application, there may be more or less of, there may be a whole QA team. There's testing engineering is a whole field of its own, which actually I think is really cool. Like if we're writing aviation software, like there's definitely going to be like software engineers who just specialize in testing for that. So all these things together are what produce software quality. And testing is extremely important, but it's only one piece of the puzzle. Um, yeah, that's a great question. And tests break because there's good tests and bad tests, right? A test that's kind of hacky or brittle, if someone changes how some of the code works, the code might still do what we want it to, but it breaks how the test works. That happens all the time. I'm sure you all have written enough code that you can imagine that now. Um, when, software packages update, that can break tests. Unexpected bugs can break tests. And then just as software complexity increases, that can cause tests to break too. So you're absolutely right, Nick, that there's a lot of value to be gotten from tests, and that's why they stay in the mix. Um, there is definitely a maintenance cost that goes along with tests. And in a lot of ways, a lot of these software best practices are good because they don't just make it easier to design and maintain the software, but it also makes it easier to test and maintain the tests. And the two kind of go together. All right. And in fact, this is a great segue to talk about testing. Um, And could I get a volunteer to just read really all of part one and part two here?
What is testing? Testing in software development is the process of evaluating a software application or component to identify and fix issues, ensuring it behaves as expected. Testing helps developers catch bugs, ensure reliability, and maintain the quality of their code. Types of tests and their capabilities and limitations. Unit tests. Purpose. Unit tests focus on testing individual units or functions of your code in isolation. These tests help ensure that each function or module behaves correctly. Capabilities. Unit tests are fast, pinpoint issues, and provide a strong safety net for refactoring, aka cheap. Limitations. They may miss integration issues since they test components in isolation. Integration tests. The purpose. Integration tests verify how different parts of your application work together. They check if various components integrate correctly. Capabilities. Integration tests identify issues related to component interactions and data flow. Effective, but still on the less expensive side. Limitations, they can be slower than unit tests and may not catch all issues. And finally, end-to-end tests. Purpose. End-to-end tests evaluate your application as a whole by simulating user interactions, providing a realistic view of its behavior. Capabilities. End-to-end tests catch issues related to the entire application, including user interfaces, very effective and expensive. Limitations, they are slow and brittle, making them costly to maintain.
Awesome. Thank you, Nick. And if you guys think back to the OOP assessment, you guys encountered, I think, all of these different kinds of tests. Like for example, a test that was using monkey patch to fake command line input. Remember the video store program for the OOP assessment? What kind of test do you guys think that is? A unit test, an integration test, or an end-to-end test?
Maybe end to end?
Yeah, exactly. And sort of a good clue that something is an end-to-end test is it's simulating what the user does or how the program is used. And like with an end-to-end test, and let me grab I'll just use a Zoom annotator here. If we imagine the program as like a black box, right, with input going in and then, some sort of output coming out. My end-to-end test is looking at the inputs and outputs to that black box. Right. And so when a program is meant to be interacted with by a user, we simulate the user input and we look at the output of the program as a whole. And in here, we might have a whole bunch of different classes, just like we did with the video store program. Our end-to-end test doesn't care about what's happening inside the black box. This is great because it makes sure that the program is behaving as expected, that all the pieces are working together. End-to-end tests are really high value because you test a whole bunch of stuff, right? And if you sort of imagine some sort of like flow chart or like other visual way of imagining your code and the different parts of your program, an end-to-end test is testing the whole thing, right? Because for the video store to work, we got to go from this class to this class, and then we got to go over here to do something. And then the part that prints the command line output has to do its thing. And so with one end-to-end test, I'm testing a whole lot of code, right? But as you saw, like with Monkey Patch, end-to-end tests can be trickier to set up, trickier to maintain, and more work. Um, Also, while it, it's somewhat common, but you could have an end-to-end test working, but maybe some internal part is not behaving the way it should. And also, for a command line application, an end-to-end test can run pretty fast. But if we have a full stack app that needs to hit a database and like make a bunch of API calls, an end-to-end test might take, I don't know, maybe 20 milliseconds, maybe even half a second. And if we have like 50 end-to-end tests, then that starts to add up. And now my end-to-end tests take seconds to run. And now, not only as a developer running end-to-end tests, but if I want to have some sort of automated process that runs all the tests before deploying code to the live production environment, which is what DevOps is all about, is sort of automated testing pipelines, then having like how long a test suite takes is a very big deal. Um, any questions around end-to-end tests? Cool. And what we're going to learn about with Cypress today is, in fact, end-to-end tests, because for front end, you do get a lot of bang for your buck here. And also, since it is a little more complex to set up, like once you get comfortable with end-to-end tests, the unit and integration tests are easier. Um, an example of a unit test from the OOP assessment would be tests focusing on a single class. Does the class instantiate correctly? Does this class's method do what it should? Right? And then integration tests would be interactions between classes. Maybe the method that returns a video or creates a customer, right? Because that method might call some other class to do work. And so it's testing how different parts of our application work together. Sometimes the difference between these can be a little fuzzy, but that's really the distinction. Like unit tests, a good signal for unit tests if you're testing, an individual function, if you're testing an individual class or its methods, and if the test is really just about this class or function in isolation. If the class or function is calling like other meaningful classes or functions, then we're probably looking at an integration test. So unit tests are usually the easiest and fastest to create. They kind of have lower value, but they're cheap. Um, the way I think about a program, and we'll see this really in Django, but a program sort of has layers like an onion. And I might have code that calls sort of like my core code right here in the center. And it might get called a lot. Say code for, if you think about data models, if you think back to like the full stack week in Flask, like a data model would definitely be at the center of the onion, right? Because it's used by a whole bunch of things. So in terms of writing unit tests, I kind of believe that you get a lot of bang for your buck by writing unit tests to target that center of the onion, right? The code that gets called a whole lot by other code. That because, like, for example, or if we were writing a function, I don't know, to like validate that an email address is correct, and then we're using that everywhere. That's a cheap thing to write a unit test for. And I get value of that because if my unit tests give me confidence in sort of the center, the core of my code, then that helps give me confidence in a lot of the other code. It doesn't guarantee that the rest of it works, but knowing that the core is good is can be really useful. Um, so I think that's a good way to think about unit tests. And integration tests, it really depends. It depends what matters in your program. It depends how much time you have. So like a testing strategy, and there's whole books on this. So this is not like a sort of learn it once or like quick to pick up kind of thing. But like your testing strategy is going to vary depending on what your application needs and depending on things like the size of your team and stuff like that. I think unit tests are good to get in the habit of writing because they're generally cheap and fast. Um, Integration tests and end-to-end tests are a little more expensive and they can be good. I think you generally want to pick like your highest value stuff to write an end-to-end test for. Like if I'm Amazon, like Amazon might have end-to-end tests for everything, but I want to make sure search works. I want to make sure that it won't let me add something to the cart, but I want to make sure that checkout works. Amazon probably has end-to-end tests for everything, but you could imagine how you might just start with like your most critical parts of the application to write an end-to-end test for. So again, it's going to vary and there's not one right answer and there's a lot of different strategies, but these are the three main kind of tests. I've kind of covered a lot of this, but we can write tests for functional logic. For user interfaces, end-to-end tests are a good use case. And then these two are good to note. Um, Unusual or extreme situations our code might encounter. If I'm writing a front-end app and I'm writing code to test the user login, what if the network is down? That's less likely, but if we're Amazon, we probably want to display a nice error message to the user. Um, Regression testing. When I find a bug, I'm gonna write a test once I fix the bug. Because if a bug has made it all the way through all this software quality stuff and still escaped into sort of the live production environment, then it's probably a non-obvious bug, and you'd be shocked how many times someone fixes a bug and then someone else reintroduces the same bug accidentally. So to make sure that that regression or like moving backwards of recreating a bug we already fixed doesn't happen, whenever we fix a bug, we write a regression test, some sort of test to test the bug that we fixed. And these are actually really high value. Um, we've talked a lot, and actually, let me just check in and see if folks have any questions about what to write tests for or anything that we've kind of been covering. Cool. Um, we've talked we've talked a lot about this. I think I've gone over a lot of the pros and cons. I'll just quickly mention a couple. Um, tests can serve as great documentation. Um, in a lot of ways, if I have a good test suite for code, it doesn't replace documentation, but it can do an awful lot in terms of if I'm new to the team. And so as a junior dev on a team, often you might be tasked to write tests or update tests because it helps you really learn not just the test, but the code base, the code that the test tests. Um, and in that same vein, tests can help with collaboration. Um, the trade-offs, as mentioned, it's definitely about time and overhead. Um, and at the end of the day, tests cannot catch what we don't test for, and there are some things that are hard to test for. So testing alone is not enough for software quality. You really need code review, you need good practices, and choosing good technologies. Test-driven development. So, test-driven development is sort of a software development paradigm. It's been around probably for a couple decades now. Um, it has gone through phases of being incredibly trendy and less trendy. You will find people with very strong opinions about it, love versus hate. There are some companies that are all test-driven development. That trend has decreased a bit, but those companies are definitely still out there. Um, that said, it's really, I think, a good mindset and it's good to know about. So the key thing in test-driven development is this idea of you write a test before you write the code. And in fact, you're supposed to write a test that will fail, then write the minimum code that you need to make the test pass. So we go from red to green. And then we refactor to improve the code without breaking the test. And the sort of strict version of test-driven development, actually, you really do this. You write the test, you write some tests first, they fail, you get the tests to pass with the absolute minimum, and then you refactor. Um, so this is a little bit of a rhetorical question, but can anyone share with me maybe a couple thoughts about like what are some benefits of if we wrote code this way and strict TDD shops, you really do write code this way. Like this is your actual workflow. And what are some of the trade-offs? Like what are some of the pluses and minuses here? Like why did people come up with this thing and why do some people like it? And why might some people dislike it?
A benefit is you kind of generate a good picture of what you want your application to look like before you start making it. And you set in the ideal world, we want our application to do XYZ, and we should write tests to do that.
Yeah, exactly. It forces you to design and think about your code before writing it because you have to write the tests. If does that sort of capture what you're saying?
Yeah.
Yeah, 1,000%. What are some other pros and cons that people see to this? And there's a long list of both.
I could see a con being it being slower. If you have to sit there and come up with and write a bunch of tests before you even start writing a program, it's definitely going to slow you down, at least in the short term.
Yeah, totally.
Um,
Totally.
maybe another, I could see, not that I agree with this necessarily, I could see someone being against the thought process of shoehorning yourself into this box of tests and then writing code based on that versus maybe writing the code, being more open-ended, and then testing it later. Maybe somebody could be against that.
I
I
think kind
totally.
of in line with that.
Yeah.
Sorry.
No, no, no. Go ahead.
I think kind of in line with that though, it does kind of avoid scope creep. Um, to keep you from like you know exactly what you need to do, so you want to test it. You want to write just to that instead of trying to go through and create all these neat functions that don't really do anything. Then that wasn't the purpose of the app initially.
Yeah, and I would say both of these are really valid cons and pros. A lot of people don't like TDD because, I don't think that way. I don't want to think that way. I might have a different workflow or a different thought process. On the flip side, if I've written a couple good tests, and often this would be, I wouldn't write like 50 tests. I would, if I'm working on a feature, I might write two or three and start there. So I don't necessarily eat the whole meal up front. So if I write the tests up front, I know really what the feature behavior is, and it helps me stay focused and not write code I don't need or go down a rabbit hole. Um, does the kind of application we're writing matter? Do you think it could impact the usefulness of TDD? I see a couple nods, and I would agree with that as well. If I'm designing a machine learning algorithm, right, or I'm coming up with some prompt engineering, or I'm, writing code to train a model like we saw a little bit with the AI stuff, TDD probably way less useful. If I'm writing like maybe some full stack web app features and I have really good specs from my product manager and for the UI stuff from the front end engineer, and I know exactly what the features are, um, like with a team that's like kind of all in on Agile and does it well, then TDD maybe is a better match, right? If kind of like the problem is well defined and we know what we're doing. So again, there's never like one right answer here, and there's definitely trade-offs. I think both of these like really capture a lot of the benefits. I'll throw one other thing in here. Provides an explicit workflow that I think is a plus. I suspect a lot of companies adopted TDD because, especially for junior engineers, it forces a workflow that has design upfront. I would say most software engineers, so there's a lot of studies. Senior engineers write code in small chunks and pushed often. And that kind of takes time because especially in the beginning, like knowing how can I break a program into little separate pieces and tackle each one is very much a learned skill that we're still learning. And over time, you get better at that. And so a lot of folks, even if they're not doing full on test driven development, you guys, when you saw me coding the other day for that to do app yesterday, you guys saw me sort of doing an informal TDD. I would write some code, I would add a console log, I would run the code to make sure that it worked, and then I would keep going. And I think that's an incredibly good workflow. You don't necessarily have to go all in, but the idea of this sort of like red green refactor loop is really powerful. The idea of I'm going to build a small little bit of my code and I more or less know what it is. Maybe it's just a comment, and I'm going to informally test it by using a console log or clicking on the app, and I'm going to make sure it works before moving on. And I think that's really powerful whether you go all in on TDD or not. Um, there's a ton of resources out here on this. This guy, Martin Fowler, wrote a great book about software refactoring and testing called Refactoring. And I'll share this link in Avenger questions. Let me drop it in there right now. His blog is actually pretty amazing. I actually need to read his refactoring book, but he's been around for ages. Um, there's a whole book on test-driven development by this guy, Kent Beck, who's also sort of one of these software engineering gurus. And this is sort of like the original TDD, and I think this is the guy who came up with it. Um, as you can see, software developers love workflows. And I'll go ahead and I'll share this as well. And I think this is probably the main thing to take away here. Um, Start paying attention to your own individual workflow. And once you start doing that, you'll start seeing how can I improve my workflow? And the more you think about that, that's really the secret to productivity is the workflow. And this is like a process that people work on like over your whole career. And I think the end goal, whether we use TDD or not, is as I write code, everything that used to work still works. The new behavior works, and my code is in a good state for the next change. Um, and even if I'm doing developing solo, it's still good to have confidence in this code. Let me go ahead and drop this link in as well. Because in my book, code has three possible states. Code can be good, code can be bad, and code can be unknown. Anyone want to guess what the worst possible state for my code to be in is?
Unknown.
Yeah, 100%. Did I tell you guys this one already? I might have. Okay.
If it's bad, you know it's bad and you need to fix it. If it's unknown, you're like, man, I don't know.
Yeah,
It's scary.
exactly. Exactly. And this works whether it's like a 5 line program or a 5,000 line program. As I'm writing code, my code is always in one of these three states. Good means I can run it, it works, there's no error, and it does what I expect. Bad means it doesn't run, or there's an error, or it doesn't do what I expect, right? We have a silent failure. Unknown means I don't know if my code is good or bad. And my guess is you all probably have spent, like, raise your hand if you spent like many hours working on code, run it, and then gotten like 5 or 6 errors, and then had to spend a bunch of time debugging. Yeah. And my guess is I don't have the full Zoom grid, but that everyone here is raising your hand. This is sort of part of the rite of passage. And as you guys have all learned, that's how debugging ends up sucking up huge amounts of time, right? It's not like when I have to debug one small thing and it takes me 30 minutes, which is not that long for debugging. But when I have like 5 things and it takes me like 3 hours to debug or longer, like a day, that's when I have problems. So if you run your code all the time as you develop and basically try to always keep your code base in a good state, so you're only tackling one bug at a time. And whether you're doing TDD or not, I think this is a really powerful software development workflow is just try to always have your code be in a good state, run it often so you catch errors early when they're small to medium, and try to keep your code to never be in an unknown state. Um, all right. That's kind of, I think, most of I've done a lot of talking here, but we've covered hopefully some good ground that's kind of sets the stage, especially as our programs start to get bigger. Do folks have any questions around TDD or testing or this sort of software development workflow stuff or stuff that you're curious about that's related to it? Okay, cool. Let me talk briefly about these test frameworks and then we'll take a break. Or do you want to break now or keep going for a couple more minutes?
Keep going.
All right, let's do it. So, testing frameworks. Let's start with Puppeteer. because it raises the sort of more interesting question. And the question is, if I have a front-end app, how do I write an end-to-end test? I need to simulate the browser. I need to simulate interacting with the browser. I need to be able to click in stuff and type stuff. How can I write an end-to-end test for a front-end app? And the answer is actually for end-to-end tests, we do indeed run the browser. And there's this thing called, oh, interesting. Someone has a site on it. A headless browser, which is a web browser without a graphical user interface that we can control with code. And this is almost always used for automating and testing. Sometimes it's used for web scraping. And so there's a headless browser for Chrome. There's a bunch of different ones out there. Um, Puppeteer is a library for kind of providing, as it says, a high-level API to control Chrome or Firefox. So especially for a headless browser, this is a great use case. So now I can actually run front-end end-to-end tests if I want on the command line or on a virtual server in the cloud because I can run a headless version of Chrome. So the browser is running, but there's no GUI, so it can run on a server just fine. And I have this JavaScript library that lets me drive it, so to speak, and interact with it to do all the things we might normally do as a user. So this is kind of the big reveal for front end end-to-end testing. Um, I just want to check in and see if folks have questions around the sort of main concept there, and also double check that that makes sense to folks because this is sort of the key element. Cool.
I have a question. Sorry, I didn't raise my hand.
Oh, go for it. No worries.
Is the live extension on the VS Code or the Vite have anything to do with the headless browser?
Great question. No, it does not. In VS Code, that you mean this sort of, if I can find it, this go live button here?
Yes, that's right.
Yeah, exactly. So what the go live button does and what the Vite dev server does is this runs what's called a server program, a web server. So it's just the same way we wrote in Flask in that full stack week. So this is running with Node.js, some program that's listening for HTTP requests on this port. And when it receives one, it does something. And the dev server, excuse me, just sends back index.html. Um, and Go Live is doing the same thing. It's running a little web server, but it's bundling some other stuff up to make it easier to use. It looks for an index.html and it serves that page, right? The client makes a request to the server and the server serves us index.html or, catpics.html or catpic1.jpg or a CSS file. Does that help answer your question?
Yes, thank you.
Totally. Yeah. And we haven't really dug that much into npm run dev or the other stuff. So that's a good question to ask. What we can look at later is what sort of npm run dev does under the hood, which is this what's called a build step, where it's bundled up all of the JavaScript and it's sort of shortened all the variable names and it's bundled up all the CSS into a couple files that are then added as script tags to an index.html. And so whenever I run npm run dev under the hood, it's also sort of running a build step more or less. But which is also how, by the way, that JSX, if we look at, this weird syntax of having stuff that looks like HTML in JavaScript, that gets transformed or transpiled into normal JavaScript. Like somewhere in here. Here we go. That JSX div element gets transformed into document.create element div and so on. So basically it gets turned into normal JavaScript. So there's definitely more going on under the hood with npm run dev, but it's not related to a headless browser. Yeah, great question. What other questions do folks have about headless browsers or this idea of using a browser for end-to-end testing? And I'm curious if there's like a nice image here. Yeah, probably not. That's okay. There's in fact whole companies that provide like end-to-end testing suites. Um, I'll share this link with people as well. This is a good one. Um, Speaking of end-to-end testing, a headless browser will execute faster. We get some increased reliability. We can add it to pipelines for DevOps and stuff. So there's all sorts of useful things here. What we're going to learn in sort of part 2 of the lecture is a front-end testing framework for end-to-end testing and other kinds called Cypress. And in fact, this will let us use a headless browser or a non-headless browser to run end-to-end tests. And sort of the example we're seeing here, which we'll see in part 2 of the lecture, is I can run my end-to-end tests with it. It drives the browser, but we get to see it. So a non-headless browser, which can be useful because I can see what's going on. And in fact, like front-end engineering teams use Cypress not just to run the tests, but they often record a video or they do like they'll take screenshots of different parts and can like compare the test suite can compare screenshots against each other as ways to catch visual issues, which again, if we're Amazon, really matters. We're only going to scrape the surface of this, but Cypress is pretty cool. The difference between Cypress and Puppeteer is sort of lower level, while Cypress is a much more developer-friendly framework for writing tests. And after the break, this is what we're going to do, where we see code that sort of looks like writing, element selectors to visit a page, to get an input, to add text into an input, right? So it's sort of like a better or a different version of monkey patching. Um, there's different test frameworks really for different technologies, right? Django, which we'll learn about later, a backend web application framework in Python, has a couple. We're going to use a library called Django REST framework, and it has a whole number of libraries dedicated to writing tests of all sorts. Django itself, the Django web framework, comes with some built-in classes for testing, and it uses the Python unit test library, but builds on it. And the Django docs walk through how to create some tests. In addition, we're not going to really talk about unit testing in React, but you can use, we've seen Jest a little bit, and you can use it. We'll just go to this free code camp article. I just want to find some example code to show. You can write unit tests in React as well. It takes a bit more effort, so we just decided we're just going to take you guys straight to end-to-end tests, since that's sort of like the most interesting. Let's see here if they have an example of a test. Yeah, this might be a little hard to read, but if I'm writing Jest, I could render a component, I could pass in data, and I could have an expect argument. And we're not actually creating DOM elements. We're just looking at sort of the React virtual DOM and examining what's in there. And so this is how we would write unit tests in React. As I said, we're not going to cover this. We jump straight to end-to-end testing because it's a bit more powerful on the front end. And I think once you get comfortable with that, this is easier to pick up. But I did just want to show this to you all briefly so you can see what it is. And I will share this link as well. All right, any questions or stuff on people's minds before we take a break? Okay, let's take 10, and then when we come back, we're going to learn how to set up Cypress. Gotta go to the table of contents. When we come back, we're going to learn how to install and configure Cypress, and then we'll write some tests for this to-do app. All right, gentlemen, thank you very much, and I'll see you all in 10 minutes. All right, so we've been talking a lot about testing and TDD. Some notes here. We did a pretty good deep dive into the value of testing, how testing is one important aspect of software quality, of how while this is not maybe the most exciting part of engineering, it's very much a real world engineering value, especially if we're going to make changes to the front end UI of Amazon.com's $1.3 million a minute money machine website. Why testing is important. And the difference between unit tests and end-to-end tests and integration tests. And now we're going to use Cypress, which is an end-to-end testing framework for front-end applications. So I've got this to-do app already set up that we were working on the other day, which has, just to recap briefly, and let me give us a little more real estate just to look at this for a minute. We were using Tailwind, and we have tasks, and there's a task class, and the task class has a checkbox, and when you check the checkbox, it changes the color of the task. And that's about it, though there's some nice responsiveness built in here. So we're going to install Cypress. We're going to kind of walk through the basics of how to use it. And then we'll add some tests for things like making sure these elements exist, maybe for adding a task, and maybe to check that the functionality of this checkbox is as it should be. All right, so let's dive on in. Okay, let me just pull up my guide code here. So installing Cypress is pretty straightforward. And let me go ahead and pull up the docs. I think it's always good to have the docs sort of at the side when doing this. So it's pretty straightforward. We install it. We are going to use this flag with npm save dev. And can anyone tell me what that flag does? We may have seen
Updates the package.json.
Say that again.
Does it just update the package.json, or is that by default what it does?
It updates the package.json, but what it does is we can have two kinds of dependencies in package.json, dependencies and dev dependencies. The difference doesn't really matter for us right now, but that npm run build command I very briefly demoed will only look at dependencies. Basically, when it's time to like install all the npm packages we need to actually run our application, we can tell npm to only look here. I don't need Cypress to run my application. right? I need it to help develop my application. So this doesn't matter for us now, but when we want to like say install, build, and deploy our app onto a server in a live environment, this can be really useful because it cuts down on the amount of stuff we need to install. Does that make sense to folks? Cool. For now, if you're not sure, just do install, dash dash save. But for stuff like, a testing library obviously is not going to impact how like our actual running of the application. So for stuff like that, we do save dev. And you can see in here like Vite, our linter, and other stuff is in here as well. So there's a little bit more that we have to do with Cypress. Let's skip through all this stuff. I'll just go ahead and kind of talk us through this one because the way we have you guys set it up is a little different from the Cypress docs. Um, and I am pulling from our curriculum lesson today. So everything I'm about to do is documented in the curriculum repo. So now that I've installed Cypress, I need to create a config file for it. And this is a pattern that you'll see more and more in the front end world. Same way Vite has a config file, Cypress has a config file. And we're going to actually import this define config method from Cypress. Oh, forgive me. Actually, let's see if we can find that real quick. So this is where like our docs are a little different than define config, and we're only going to scratch the surface. We don't need to configure all of these things, but you can see we can set the port that the Cypress browser is going to use, the number of retries, if it watches for fails, timeouts, which is how long Cypress waits between running commands if we want to set different timeouts for different things, where to find different folders. If we want to use Cypress for screenshot testing to take screenshots of the application, which we're not going to do, where those screenshots live. If we want Cypress to actually record a video as it clicks through and does stuff in the UI, where those live. So you can see setting default browser, which we're going to do manually, and just a whole number of things. These ones we actually are going to use a little bit. We can set a default height and width of our browser viewport. And let's see if we can find that define config method. Yeah, I thought this page would have maybe a bit more of a description of it. It doesn't. That's okay. Let's start building this out. Excuse me. So we're going to import this define config method, and define config returns a config object that it does some extra stuff with, and we're going to have that be the default export of our Cypress config file. And this is where we can add all these different properties. It is where I would have liked to find. Here we maybe is this. Somewhere in the Cypress docs, we can find like the API that walks through the configuration of all these things and all the different options. But we're going to set on the config object a couple things for the end-to-end testing property. We need to tell it what URL to look at. And this one should ring a bell. So we need to tell Cypress when it's driving the browser, that it should make initial request to the URL and the port that our React app is running on. We don't need to load any support files, so we're going to set this to false. Daniel, yes, sir.
If we have multiple web pages, will it navigate between them? Basically, like if that is the default home page, but then say you click into a like let's say students, and then it goes like / students / will it actually navigate to that, or will it just be stuck on the home page or whatever you set as the base URL default?
It will navigate to them. Yeah, great question. And I didn't describe the base URL all that well. I think the pop-up here does a better job of describing it. It's the prefix, right? So when we're using the commands to visit or navigate to a URL or make a request, like I could do, excuse me, if I do side visit, oh, how about let's just the base URL is what comes in front. Does that make sense?
It does. Thank you.
Yeah, great question. Thank you. And sorry for the confusion there. And we're gonna set also in our configuration the viewport width and height just to do it and just to show it. And we are gonna tell Cypress not to record videos. I think it might record them by default. So this is important because videos just take time. We can set this to true if we want to play around with it later, but it makes the tests run longer and it generates a whole bunch of video files. And this is really all we need for a basic setup. What we're also going to do now is add some scripts to package.json for running Cypress. So there's two commands we need. One is to open Cypress with a user interface that we can interact with and see. And the command for that is open, Cypress open, which would be run from the command line. And then we need a command to run all of the Cypress tests. And we can use this command too from the command line. Search for all the Cypress files, which we don't have yet, the test files, and run them. So now let's go ahead and let's do npm run sci open and see what happens. So you guys didn't see it pop up, but on my other monitor, this is what popped up. And you guys can't see me alt tabbing because it's showing up on my other monitor, but this is its own program. And in just a moment, we're also going to have another browser up and running. So we want to choose the end-to-end testing option here. Component testing is sort of a separate thing and more of, it's like an end-to-end test for a single component. It's a little more complex. So we're just going to do full-on end-to-end testing. Cannot connect URL base. Warning. So this raises a really good point. Cypress needs our dev server to be running because it needs to send HTTP requests to that server to get back index.html. So Cypress is telling me, hey, there's an issue here. I see that I'm not going to be able to run tests. So let me go ahead and do npm run dev. And let's try again. And now that's working. And again, the context here is, let me grab a TL draw real quick. We're going to have a browser controlled by Cypress, and it's going to make a GET request, like say get HTTP localhost 5173 index.html. And let's make this a nicer, straighter arrow. And so I need to have my Vite dev server running so that when this request is made, there's a server application running to receive this request or any other request and send back data to the browser, which is exactly what happens when we're opening up this, right? This is the exact same flow. And I just want to check in and see if folks have any questions there. Cool. So now we choose a browser that Cypress is going to use for end-to-end testing. This is kind of important. For those of you on Windows, I think you will have to choose Chromium. Don't quote me on that. I believe, start with Chrome. If you, I can't remember if we had a WSL issue or if I'm getting Windows users confused with Linux users. Let's start with Chrome. If you run into an issue, try Chromium. Chromium is an open source version of Chrome. Electron is, in fact, what Slack is built in, and it is sort of like a, I think it's like a browser engine designed for building desktop user interfaces, essentially. Very interesting, but out of scope. So try Chrome. If you're on Linux, you'll definitely need Chromium. So Kevin and I believe someone else might be running Linux. You guys know this, I think, but you want Chromium. Windows folks, I think you're okay on Chrome. I think the WSL2 port issues should be resolved, but if anyone does run into those, let me know. And again, Windows folks, if you run into an issue, try Chromium. I have a vague memory of that. So now we've got Chrome open. And in fact, if you alt tab through all of your open applications, you would see that there's actually two different Chromes running. We have this interesting Chrome is being controlled by automated software message here, which I'll just close out. I'm not going to worry about logging in. I'm actually not sure what that's for. We can see the specific version of Chrome. If we want to switch browsers, we can do it here. This is actually really nice. It gives us, we can open up all the different Cypress references, which we don't need right now. And if we look over here, spec is short for specification, which is another way of saying tests. So you'll often hear people call tests specs. When we actually run the test suites, we'll see the output here. We'll see debug messages here. And there's various settings here, which you shouldn't have to mess with. Cypress Cloud, we don't need to worry about. That's more for like, teams and production environments. And we are going to just run all this locally. What we do want to do is click on this scaffold example specs option. And when we do, it's going to do a couple things. And note, by the way, I still have this Cypress running in the background here. So scaffold example specs is going to create a Cypress directory. And inside that end-to-end test directory, and it's going to create an example test. So it's going to create some directories that we need. We could create them manually, but there's no reason not to do it this way. And they're showing us what we just did. And in fact, I can see now here, there's the Cypress directory /e2e, and they've added in some example tests. And in fact, they have a whole lot here, which is kind of cool because you can take a look at some real world test examples. And they've just shown us a list of things. And so now, if I look here under specs for the tests, we see this end-to-end test directory, and we see all these different tests. I don't think this test is going to work. Oh, actually it does. They must have added HTML page or something. So we'll build our own test against the to-do app in a minute, our to-do app, because this is an example app that they have example code for. But you can sort of see here a higher level description and all the different explanations of the test. And then in fact, I can click in and I can see the different Cypress commands. And if I hover over it, I see that before each test, this happens. Ah, I see how they're doing it. They're going to https example.cypress.io to do example.cypress.io to do. So this is, I actually hadn't realized Cypress did this. This is awesome. They've made a simple to-do app that they've hosted on some server live. A much nicer looking to-do app than ours, though we could totally build this if we wanted to. Actually, I love this 2 items left, 1 item left. I feel like we actually Code Platoon should steal this as things to add. And in a moment, we'll look at the Cypress tests that run this, but this is so their tests actually go to visit this live site. And then you can see these commands that use the element selector syntax that we're familiar with from like document.getElement by ID. And we grab a list element, we can see an assertion. We can see like, as I click through, I can see sort of what the browser is doing for each of these tests. And you can see here, like the test descriptions are really nicely named. And again, we can see get, we see a type command, we see an assertion that we expect to see a new list item in here, and so on and so forth. So again, I think Cypress is pretty cool, and it's pretty cool to see all of this in action. I'm not going to worry about these more advanced examples. So again, specs is where you can see the list of the different tests. If you go to runs, oh, it looks like we have to connect this to Cypress Cloud. So we're not going to really worry about runs, I don't think, unless it shows up when we run tests locally. Because when you click on a spec in Cypress, it will run it for you. I think when we run it locally, stuff might show up as well, but we'll see. So let's put that off to the side for the moment. Let me actually check in and see if any folks have any questions before we start looking at some of the Cypress test code. Cool. How are we doing? How are we feeling? Pretty good on a scale of like 10 to 20? Andy, yes, sir.
It's not as a question. It's more so I have technical issue with the Cypress, can't install it, but we can go into that later.
Okay. Yeah. If you don't mind, just put the error message that you're getting. Are you getting an error message on the command line?
Yes, I am.
Just put that into Avenger questions and tag me on it, and we'll take a look at it.
Okay.
Yeah, and thank you for letting me know. All right. So we've added NPM scripts for Cypress. And again, all of this is in our curriculum lesson for today. So you don't have to worry about remembering all this. This config is also in there. It's pretty minimal. Really setting the base URL, the support file, and video to false are the key things. And again, this is in the curriculum repo for today. And just getting used to the Cypress UI is part of the goal for today as well. And now if we look at the tests that they had for their to-do app, we can kind of see what a Cypress test looks like, and then we'll write a couple of our own. So they've added some really lovely documentation here. They have a live to-do app up and running. They have a whole getting started guide. And you can see that they use these describe blocks to organize their tests. And this is a description. Can I get a quick show of hands? I know we talked about Jest way earlier. Have you all seen like describe and it blocks before, or is this sort of a newer thing to see for folks? Or somewhere in the middle?
It's new for me.
Okay, perfect. Yeah, I imagine it's new for a couple other folks as well. All right, let's talk through this. The thing to remember is for Python, it's an object-oriented programming language. It sort of organizes its world with classes, right? JavaScript has objects, but it really uses functions in a lot of ways to organize its world. So if you guys think back to unit tests, how you might have in Python like different classes for your different tests, here we have functions. And so this describe function is sort of automatically imported for us. I think that actually comes from Jest, but Cypress is using it. And this describe function takes two arguments. The first argument is a string. That's the name of the test. And let's actually go to the spec file here and look at it. And we see right here, example to do app, and that's coming from here. And if I added 3 exclamation points, we would see that change. And the second argument in this describe block is a function. And if we look here, we see here that this is a really big function. It's an arrow function that's basically a container. So we're passing a function as an argument. And what the test suite does is when it runs the test, it prints this out, and then it executes this whole function. And if I wanted to, I could have describe blocks inside describe blocks. We'll get there in a minute. And then inside this sort of wrapper function are a bunch of other functions, again, imported by the test library. And they all follow this same pattern of they take one, one or two arguments. This before each function describes a hook function, right? We've seen that word with React, or a callback. And this gets run before every single of these individual tests. And this it function is one specific test or spec. And the first argument, again, is a title. The second argument is an arrow function, and this is what gets executed when the test is run. And it's sort of a container for our code. So we have this before each function that takes in an arrow function, and it's saying for each one, hey, browser, make sure you go to the Cypress to-do page. Then we have all of the individual tests. And let's go ahead and, in fact, close these out. And we'll open up the outline in VS Code. I think this is a nice visual aid. And so we can see here this first test. The first argument is the description. The second is the callback function that gets executed to run the test. This object Cy, which is short for Cypress, gets imported for free by the test suite. So because this code is run by other code, we don't need an import statement here. And this is where, if we looked in the Cypress docs, we could see all the different commands to do. And this makes, this says get an element. And here we see a selector. And it's saying look for an element with this class, this CSS class, that is a list item. And it's saying, and get will return an array. So as the description says here, get one or more DOM elements by selector. And this all comes from jQuery, which is this JavaScript library that before React was sort of how everyone used to do all this stuff. And we see a couple examples here. We see, how I could find all the list items in some element with the class list, or I could find the unordered list element and grab the first one, or how I could find the element that has the class drop-down menu and click on it. And get, I believe, usually returns an array of DOM elements. If it returns just one, it may not return the array. And you can change stuff on here like we see with the .click. So I've been talking a lot, so I just want to pause and see if folks have any questions, especially as I think some of like using JavaScript in this way is a bit newer with the callback functions and stuff. How are we doing? Cool. So again, main thing to remember here is this it method function is an individual test. The first argument is a string that's a description. The second is an arrow function that is not called right now. Cypress executes it when it runs the tests, and here's where we put in the test logic. And we can use this sort of element selector sort of syntax to grab different elements and do all sorts of stuff to them. Like we can grab the first, we can grab the last, and so on. So let me just pause here and check in. What would be useful for folks? We could kind of walk through this in a bit more depth and kind of also look at the actual test as it runs, because I can actually go in here and I can open up developer tools. Right, and we could kind of do that side by side comparison, or we could open up the live Cypress site and do a comparison, or we could write some tests for our to-do app. Andy, yes, sir.
I would appreciate some insight on what maybe to expect on the assessment for what the Cypress looks like, the tests, just to get a hang of it.
Yeah, totally. Like with the OOP assessment, you won't have to write tests. Rather, there will be a test suite that you have to pass, and you'll have to read it. And actually, this example here in the to-do example is a pretty good example of what you should be comfortable reading in the test suite. If we sort of look through this, we see that we're looking for different DOM elements. We're looking to see that they contain desired text. We're finding its parent. We're checking, checking or unchecking input fields. We're checking that certain elements have a desired class. So there's a decent amount of stuff in here, but there's not anything super crazy. Does that help answer your question?
Yeah, it does.
Awesome. Yeah, you guys aren't going to build a to-do app and you're going to have to build something that gets data from an API, but it's going to build on and be familiar to stuff that we've been doing here. What other questions do folks have? Should we write some tests of our own?
I have
Yes.
a quick question. So for like all of the dot commands like dot should, dot first, dot find and stuff like that, is there a convenient list of like all the commands that we can utilize in one spot?
Yeah, the Cypress docs are pretty good on that front. Let me go ahead and in fact pull them up and let's actually take a quick look. Because that's a good point. So the Cypress docs are pretty good. I would just recommend reading, I think probably like all of their core concepts, definitely the first several parts. Like here's a very nice example of a simple test where I can use dot visit to go to a particular page. I can use dot get to grab an element from that page that matches a particular selector. In this case, it looks like I'm looking for an input element, and inside there, an input element that has maybe the class, the CSS class post title, and I'm using this command type. So I would definitely like read through this. Again, it borrows from jQuery, which it used to be like the tool to use to interact with the DOM, and then over time it kind of got replaced by React, but this sort of selector syntax has remained, and in fact Cypress jQuery's is still out there. Right? Cypress will automatically retry queries until it hits a certain timeout. So it'll try a couple times. It'll wait a bit. It can do more powerful stuff like containing new posts. It can look if elements are missing. As shown here, you can chain commands. And in fact, here's a list of the different ways you can interact with a website with the DOM. Right? I can make a DOM element blur. I can focus on one. I could clear the value of it. Here again, we see the example of typing in a text input with type. There's check, uncheck, select, double click, right click. A list of some good examples of assertions and the syntax for them, such as if an element is or isn't disabled, if an element has or doesn't have a CSS class, if an input field or some inner HTML does or does not have a certain text value. Here, if we go through assertions, it has a list of all the different assertions, but just to kind of, I think, keep going through this for a bit. And this is why I think this is a good starting point because it kind of covers the most important stuff. Testing types, we probably don't have to worry about. Writing and organizing tests is probably good to read a little bit, but it's really interacting with elements. Variables and aliases, we don't need to worry about too much. And then the guides might be a little too in-depth. I don't think the guides are where you want to go. But then, like all docs, they always kind of bury stuff here. They call it references or they call it API. And so here we have a list of all the different assertions, which is pretty comprehensive because it's pulling from this other library. Excuse me. Here we go. So this, I think, is a list of commands. So API is, I think, closer to what you want, where we can see like a list of the different commands. Right, getting all the children of an element. Getting the last DOM element from a group. And then on this API page, if you look here, I'm not sure here if the API will. I'm not sure how much that part will be useful. So I think commands and like that first part of the getting started guide are probably going to be the most fruitful in terms of finding different Cypress commands. Honestly, though, I actually had not seen this test file of theirs before. I actually think this does a very good job of like laying out sort of the bread and butter commands that you'll be using 50 to 75% of the time or need to understand with Cypress. So I would just start here with their to do. Does that help a bit?
It does.
Yeah, I realize there's not like one page that kind of has all the key stuff. Some websites have better docs in that regard, others don't. But I really think that getting started guide and the first couple parts of this, and then they have a search to search through stuff. Like, so I honestly, like, I would recommend just read through this, and when you get to something new, Like maybe I want to get more familiar with sci.get. Like I would just look it up as I go because the the comprehensiveness of the docs is almost it's a double-edged sword, basically. Right? The docs are extremely comprehensive, but that's a little bit of a double-edged sword. So start with the getting started guide and the actual Cypress to do here. And I would just look these things up as you go. And I think that's going to be by far the best bang for your buck in getting comfortable with things. Yeah, great question, man. And again, I think the first couple parts of the core concepts, like the introduction, testing types, but in particular, interacting with elements, like this is where I think you get a lot of your bang for the buck. And actually, I'll put this in our questions channel. Do folks have any other questions or things that are on your mind? All right, why don't we take a short break? Let's take 5. Let's let our brains recharge, and then we'll write some tests. Sound good? Awesome. Thank you, folks, and I'll see you all in 5 minutes. All right, so let's write some Cypress tests of our own. So I've just added in the Cypress/E2E end-to-end directory a subdirectory for my tests, and I've made a file my-to-do cy.js. As you can tell, Cypress test files do need .cy.js as their file extension. And the reason is so that Cypress, that's what it searches for within this directory is that .cy.js extension. So let's write a couple tests. Let's write something just to confirm that the H1 exists and has correct title, right? If we look at our to-do app, let's make sure this H1 is there and that it says to-do app. Let's confirm the input element exists. Let's confirm the button exists. And let's confirm the H1 input and button all have the animate bounce class. Since for our $1.3 million a minute to do app, our user experience researchers have determined that the bouncing icons, cause people to spend way more time on the app. So this is actually like a really mission critical feature. So we're going to start with this stuff. And then once we have this done, we'll do something a little more advanced. We'll confirm there are the correct number of default tasks. Confirm for a default task, it has a checkbox and the right text. We should confirm if we check the checkbox, the task message changes color. Hopefully we don't run out of time, but then we also should try like adding a task. So this all sort of falls under the category of like task display. And in fact, confirm for a default complete task text color is correct. And confirm for a default incomplete task text color is correct. And we'll just sort of call this general app display. And then we'll do, let's call it task interaction. Adding a task the task is added. And it should be added to the bottom of the list. So we'll see if we have enough time to get through all of these, but I think this is a pretty good list of stuff. Anyone have any requests maybe for like additional tests to throw in the mix here for us to build?
For the task display, maybe check the day night mode for React.
Oh yeah. I thought about that. I don't have, we can check. That's a good call. Confirm the dark mode CSS class is present. I don't have like a button or something I can check to make sure like whether it's in dark mode or not. Because I was thinking about that because that would be a great one. And the way that Tailwind works, if we like go into the div, where did we hide it? On this H4, the dark text white class is always there. It's just Tailwind does the work of figuring out if we should use it or not based on, if we have dark mode here or not. So so there's not like a CSS class that comes and goes, you know what I mean, that I can look at to confirm that it's being set up correctly. There might be a way to get fancier with Cypress to do it to see like what is the actual color of this, but that gets more complex. I would say that that one gets a little trickier. In some ways, what we would want to look at is the React component state to see if it gets modified. There might be if am I understanding your question, your thought correctly, Daniel?
You are. I'm just trying to see, like, basically if it exists in, I mean, the functionality of it, I guess, would be a different style test, but just, I guess, to see if it exists would
Yeah,
be a good test.
yeah, yeah. And this points that one like some of the real world challenges of testing, right? And of making end-to-end tests is it can be more challenging to test certain kinds of behaviors. And because of how Tailwind works, this is a little trickier. I'm sure there is a way test like actual color of elements. Yeah, this I'm not sure if this I think this would let us look at the color of the element rendered. Let's see here, dynamic color changes. So, such as after a user interaction. Yeah, this would be a great one. I might have to like dig into this a bit more. Um, I bet Cypress can do it. I don't know how to off the top of my head. So in the interest of time, I'm not going to do it. But let's see here. Here we go. So they have it in a blog post. I'm sure they have it in the docs. Yeah, we'd have to see if this I think this would give us the actual color value of the rendered element, but I'm not sure if it gets us that or the CSS rule. So we'd have to test that out, but that's how we would do this. And I'm pretty sure Cypress can. Um, and then we also just have to get the correct RGB color because this looks like, I think exactly what you're talking about. So let me put this in the questions channel. And if someone wants to play around with this, I actually think that would be awesome to do this afternoon. But for now, just in the interest of time, I'm not going to open that door. If we have time, we'll take a look at it because I agree that would be awesome to see. All right, let's start writing some code. So I'm going to make a describe block for this whole section, and we're going to call it describe general app display, and it's going to have an empty placeholder. and I'm just going to grab these, and we're going to say uh, title element renders with correct title. So I want to describe functionally what the test is testing. And now inside here, we're going to visit our app because we've already set the base URL. And we're just going to use get, and we're going to tell it to look for an H1 element. And we'll call first to make sure that we grab the first one in case there's more than one at some point, right? If I had an ID here, it would make it easier to grab. But we can do it this way and grab it by the element type. Carlos, yes, sir.
Real quick, I'm assuming that before each line, that would only really be used for if you're actually changing pages, right? So since this is a one page, we're not really going anywhere. We don't really need it.
That is a really good point. The before each here. Yeah, we don't need it. I don't know. You know, they probably did it because they can't rely on the Cypress config file being set. Because in our config, we set a base URL here. That said, you know, actually, we may want to end up adding a before each. I think I may end up adding sci.visit a whole bunch of times. Um, you're probably right. We probably do need to add a before each. Let me write out a couple of these, and if that's correct, I'll refactor it back in. Yeah, excellent point. Um, I think you're correct. We probably will need to do that. Sometimes, to be honest with this stuff, like if I'm not using the library day in, day out, I'm not always certain of the behavior. Um, so sometimes it's easier for me to just run it, and then if it breaks, fix it to make it right. Let's get this one working though, and then we'll tackle that because I think you are right that we'll probably have to end up doing that. So I can add a should assertion here, and we'll just say contain. Sorry, I'm looking at some guide code to do app. And let me go ahead and just run this in Cypress to make sure that I have stuff working right. So let me switch over to Cypress and let's full screen this for a moment. And let's see how we do here. And
Did your server crash?
I don't think so.
Is the HTTPS versus HTTP, can that break it?
You know, that is almost definitely the mistake because the to-do app is indeed localhost 5173. The server is indeed up and running. And in my Cypress config, I indeed added HTTPS, which is a huge problem. Great call, because it's looking for an SSL certificate, which does not exist. So it looks like Cypress reopened itself. So let's try this again.
I'll eat later.
And if I click on my to-do, we see your tests are loading. We see our to-do app. We see it visits the site. Carlos, I think you're going to be totally right here about the need to add the before each. We get the H1. And what's nice is we see the element selector sort of highlighted here. And again, you can open the element tab here, which can be extremely useful for debugging tests if a test is not doing what it should, because then you can look through what you need. We see it grabs the first. We see an assertion, and I think the assertion passes. It's green. I don't see any errors. So I think that first test is good to go. And I am just going to look at, I just want to make sure I have the syntax of this right. Yeah, and so the green check and then the green dash and the green assert tells us the test passes. We would see red if it failed, and indeed we see a checkbox here as well. So awesome, we have a first test. And by the way, you can interact with this. You can add stuff in. So it's pretty cool. And I just want to pause and see if folks have any questions before we add more tests. Okay, awesome. Carlos, I think you're totally correct here, by the way, as we do this. Because now, and this is the beauty, by the way, of tests and boilerplate, is once you have one, you can just kind of keep reusing the pattern. So I think I can just say exist here. And that should do it. And let's try running the test and see how it goes. And again, I see that that works. We can see the steps here. And we're asserting that indeed the input element exists in the DOM. And, that was a great call, Carlos. I wasn't thinking, indeed, we should just add a before each here so that I don't need to add side visit every time. And in fact, let me just make sure my tests are still running. Yep, we're looking good. So let's just keep on rolling here. Again, these are simple, but our goal is just to start getting more familiar with the framework and that JavaScript syntax. And we see here that we're visiting the button element. And it might be nice for the button element. Actually, let's confirm that it contains some text and that it says add task.
Need a parentheses at the end.
Parentheses.
Oh yeah, thank you. And we actually run into an error. So let's see what went wrong. So it successfully got the button element. It grabbed the first one. It did an assertion. Let's have this run again. I know what the error is, but I want to make sure I'm getting a nice looking error message. Let's see. Timeout. Let's see if we have some nice output in the console here. So Cypress output is not so great. So this is where Cypress can get a little tricky because the error, and I did this on purpose, the T in task is a capital T, and my test is looking for a lowercase t. We don't get a great in the UI, a great way to see sort of the difference the way we would from the command line. It might be hiding from me, but that might just be the limitation of Cypress. But I did want to show what an error looks like. We at least see the part that fails. So that can help us focus on and isolate where the issue is. And now if I change this to a capital T, Cypress will run the test again, and now it passes. So we're really rolling here, and we have this describe block. Now this is done for the general app display. Now I think we may need to end up having our next describe block either in a separate file or wrapped in one big describe block. Let's see if this throws an error for us or not. And let's just grab all of these. and we should have, I believe it's 5 default tasks. Oh, 1, 2, 3, 4, 5. In fact, I'm just going to grab this and paste it in here as a reference as we're working on this. And I'm pretty sure I'm going to have to move this describe block into another file. I'm just going to grab this code from before to put it in here to run it. We also do need the before each because this is a different describe block. So again, I need to do sci.visit and go to our homepage. And I was actually wrong. Cypress seems to be totally fine with us having 2 describe blocks in the same file. I think this is fine. In general, you can actually nest describe blocks. And in general, you do want to nest them or have these in separate files. But for now, I'll do it like this in the interest of time, and I might refactor after the lesson. So we're going to need to get, and let's take a look at the structure of our app. So this is a little trickier because I did not use list items, and these are all divs. And if I'm looking at these div classes, I'm not really seeing like a very useful class name. You kind of want to avoid, like if I want to get like a task, I don't want to have to depend on like a layout class attribute, because what if we change how I handle my layout and then this whole thing breaks? So this is a great example of how sometimes writing a test forces you to refactor the code, because I think what we really need is over here. I think this div needs an ID, and we'll just call it task container. And then I think in the task class, I guess we're going to run into an issue here actually, because I can't have a bunch of divs with the same ID. I might just have to make up a CSS class here. I think to
Could
aid.
you,
Oh yeah, go ahead.
sorry, could you pass it in what you're using as the key? So the ID, pass it into here, or has it been created yet? I don't remember if it has at this point. The ID for that task and use that as the ID with the interpolated string.
The problem with that is, like, if the ID number changes, then the IDs are dynamically generated, which makes my test really brittle, right? Because then in my test, it's a good thought, but then in my test code, if I have to do like get, it might have to look something like, it might have to end up looking something like this, task ID dash. Right, something kind of funky. You see what I'm saying?
Can a
Yeah.
div can a div belong to multiple classes?
Not classes, absolutely. IDs, no. And I think that's in fact exactly what I'm going to do here is I'm going to add a class to the task, and we're just going to call it task, and it's going to be empty. And this is a bit of a hack, but frankly, sometimes you need to do this. In a perfect world, maybe this should be a list item and these should be in a list, but this will do the job too. So now I have one task container div since the ID has to be unique and there is only one task container, so that's totally fine. And then inside there, I have a bunch of divs, each of which have a class name task. So between these two things, I think I can get the job done. Um, and in fact, we may not even need the task container ID, but it doesn't hurt to add it there. And I think it's probably a good practice. So there's a couple different ways I can do this, but this is actually going to end up being the simplest, where I can use this selector syntax to say, get me all the divs that have a class task. And this is actually going to be a decent amount because there should be 5 of them. So let's call these tasks. And we can say tasks.length should, let's see if I can get this syntax right. I may need to double check my syntax there. Give me one moment here.
It was task dot should parentheses have dot or have comma length, something like that, I think it was.
Let's look it up. Cypress check number of elements. Oh, yep. If we scroll down here, here we go. Yep, you're totally right. Should have dot length. I find the syntax is a little bit of a double-edged sword for the assertions because it's like once you know it, it makes sense, but it's sort of this middle ground between code and magic symbols. So let's just see if that's working.
Beginning to remove
Does someone have a
length
question?
after task.
Say that
Yeah, I
again.
was gonna say we probably need to remove the length, the dot length, right after tasks.
Oh yeah, thank you. Okay, awesome. I think we're cooking. Should contain 5 default tasks. So it's always important when writing tests to make sure the test fails as well as succeeds. So let's make sure that this test fails, and that will be like our ultimate sanity check that we've done this correctly. And it sure looks like it's about to fail. And in fact, here we get a nicer error message, found 5, expected 6. So we now know we have the correct number of tasks. Let's now look at a task and confirm. Let's just take the first task and confirm that it renders the way that it should. So the first default task should have a checkbox. So let's do first. And now, in fact, I might need a little help. Cypress check if element has child. And come on. Cypress check if element has child. And I honestly find doing this much faster than looking up the docs. So here we go. We want the children selector, and then we can apply another selector on the children, I believe. So we can do first children get input and at this point I might start using the syntax that you all saw in there, which can be kind of nice as stuff gets bigger. And let's do Cypress check input is checkbox. And should have attribute type checkbox. And let's see if this works. And let's pull up our Cypress. And it looks like I might have done something wrong. Let's see what we did wrong. This is actually really helpful. We see we get all 5 of those tasks. We indeed got the first one. We indeed got its children. We indeed, I did something wrong with the get input. And in fact, we can see the number of like elements that match each of these selections. I'm not getting the input elements in the children. I'm getting all of them, which is definitely not what we want. So let's see what I did wrong here. And in fact, this may be a ChatGPT moment for me, because I feel like there's something relatively intuitive that I'm getting wrong. I want this Cypress code to get the input element that is the child of a div, but it's getting all the inputs on the page. Now, I can't just straight up and down trust ChatGPT. I need to have enough knowledge to like be able to assert that it's correct, because I've seen it hallucinate and come up with false stuff. But honestly, I think for something like this, where the debugging solution is reading the docs more carefully, the learning value of that is limited. And I think this is a good accelerator and appropriate to use for debugging for something like this. And it looks like I'm actually not sure exactly what a subject chain is, but what's clear is that I misunderstood how the chaining here works.
Yeah, it
And
looks like you want find input
yeah,
instead of get input.
yeah. And even more than that, it doesn't use children. And in fact, it describes it here. Find searches for input within the currently selected element. So I made a bad assumption that I wanted to use children and then search within children. But in fact, find in effect does that for me. Andy, yes, sir.
But if it's a test, why would you want to go find it? Like if it's one of the 6 would have it, but the others don't, that would still come out to be true, right?
You mean if I'm writing the test and we check that the input element exists for the first default task, what about the other 4?
Yeah.
Yeah, that's a good question. So first of all, you know, in some ways, we're kind of testing the test here. Like we're checking that our HTML does what it should. But this is actually useful, and you raise a really good point. So our React.js code renders all of these, right, from JavaScript. So the first test here that there's 5 default tasks, that tells me that my React.js code has correctly taken that JavaScript array and rendered it into 5 elements, right? So that's a good verifier that that part of that has been done correctly. Because of the nature of the code, if we go here and we hop and we take a look, because we're using a .map and because we're using the same task component, I can have a pretty high degree of confidence that if my code is correctly rendering one of these, it is for all the others, because it's the exact same code that does the rendering. You know what I mean?
Makes sense.
Yeah, and that's a great question. And again, it depends. And it's important to think about, like, what are we testing? Like the test to make sure that the H1 and the input and the button exist. Those are sort of supernumerary, but they're useful to make sure, hey, someone doesn't do something silly and accidentally delete an H1. But it's borderline, testing that 5 equals 5, some sort of self-evident. With these, it's a little bit more because we're making sure that this code correctly maps over this array and renders each of these. Yeah, so that's a great question. And sometimes you might want to get more granular. It just depends on, I think, the nature of the code. So let's see if we are cooking now. And indeed, it looks like with ChatGPT's help, things are now working. And if we look at this first default task, should be a checkbox. We get 5. We get the first one. We find the input, and we get the assertion. And there we go. And on the one hand, it might feel like overkill to have like one test for a checkbox and one test for a div. But we can see here, there's actually a decent amount of logic here. And by making this test really small, if it breaks, I know exactly what the problem is. Or if I need to modify the test, I know exactly what I need to do. We can also see here, by the way, because we're constantly doing like side.get div.task first, if we had enough of these, we might want to put it in another describe block and use another before each, but we're not quite there yet. So let's go ahead and check that first default task correctly renders task name. And after this, I think I'll pause and check in, and we should probably switch to the interactive one. I think just so we can see that built out. So again, we can borrow some of our code. And in fact, we can do, now here, it might get a little trickier because we have to look at the structure. And if I look inside here, I see there's the input checkbox, and I see this is an H4 that we're using. So that's, I think, relatively safe. If we wanted to be, and then in here, there is a span. So this is where like these tests can get a little brittle potentially. Like there's some advantage to having class names. But the truth is, like front-end end-to-end tests are always kind of brittle. Because if I change this from a span to something else, my test is gonna break the way I'm writing it right now. But there's not really a better alternative. And we can do contain text, and I love this autocomplete here. And I believe the first one should be get milk. And let's see if that's working. Let me go to our Cypress tests. and we see that we grab that span, and indeed it contains get milk. So I think we can build this out a bit more. We can task name and message. So let's we'll just put in this same task the same thing, and let's grab the H4. So this first part is the task name. This next part is the task message. And you can see here how there's like a pretty tight relationship between code and text. And surprisingly, that seems to pass, which doesn't feel right to me. So I wonder if I actually was wrong here. And so something is actually so that's what I want. It's doing. Oh, I see. So that raises an excellent point. We can actually make this a little less brittle. This contain text will search inside this H4. So we might actually be able to simplify this a bit. Let's see if this works. Let's see if this chaining works or if we run into an issue. Oh, and I need to change the span to an H4. And so this is actually great. We can have two assertions chained together. They're both looking inside this H4, and they'll look through the children of the H4 as well. And just to double check that this is working, let's cause our test to fail. And indeed, this fails because that is not the message, right? We don't have those exclamation points in there. So we can also chain a should on here, and I might need a little help. Cypress check element has CSS. Should have .css, and then it looks like the CSS property and the value. So what I want to do next is this message should be read, right? Now, I don't know the actual RGB of the red, and I'd rather frankly test for the existence of the CSS class since our code is changing that, this text red 500. So what I really want is I want to make sure, there we go, have class name. So now I could actually break this into two tests, and I actually think I will, and I'll explain why in just a moment. So one feature here is that we show the task name. But the task message changes depending on if the task is complete or not. So the first task is incomplete, So let's make sure that it's rendering correctly for incompleteness. So I want to check that it has incomplete message, and I want to check that it has incomplete styles. And I think I do need to hop back to my reference for just a sec here. And it is have.class. And
Initially, when you were kind of writing out what you were going to do, you had the message on one line and then you had the actual styles in a different test. Um, is it typical to kind of combine them since they kind of go hand in hand?
say that again.
So when we were writing out the different tests that we're going to be doing, you separated the color, the styles part separate from the actual text part. They were going to be two separate tests.
Right. Right. Good
And
question. Yeah, what I ended up deciding, and it's a little bit of dealer's choice, but in looking at this, if I think about sort of the logic and the functionality that's going on here in terms of the application, there's a couple things going on in here. One is that we correctly display the name of the task, right? And we want that to work, and that's independent of whether the task is complete or not. So by separating that into its own test, I've made testing that functionality independent of how we check if we show the right kind of message for an incomplete task. And this way, and this is more for a bigger code base or when working on a team, if we refactor, say, how this code works, then I only have to change this test. Or if we refactor how showing the incomplete message works, we only have to change this test. And also this way, if like this test breaks, it's much easier for me to figure out what's gone wrong to fix. Does that help answer your question?
yes, sir. Thank you.
Yeah, great question. I love it. Great question. And again, it can feel like a bit overkill, and it's okay to have these be in one big test. You can always refactor tests into smaller tests, but I thought this is actually a great example because it also is a great example of like the level of specificity that you can get into in testing, but some of the value of it. Um, for instance, and really, I should be adding like extra describe blocks to sort of organize these tests better, but that's okay. So, in fact, this isn't really about like whether a task is default or not. This is about rendering the incomplete message correctly. Um, and in fact, what we're going to do is we're going to have this same test, but we're going to check for completeness. And we're going to look at our last task, which is get steak, which is complete. And so a task should render correctly there, but we're going to grab the last element instead. And I have to look at the code to remind me what it should say. It should say is completed. Um, by the way, this is why if say we go to components here, um, sometimes you'll see people, it might be nice to have up here these as strings. And I might, in fact, export both of these. This is also why, like, if my tests are done and I screw this up, the test can help me realize I did something wrong in my refactoring. But so now, fingers crossed, this all works. And over here, we could, import those strings. And then over here in the tests, we could change this, and it should make those tests. Now these tests are less brittle, right? It's a small thing, but little stuff like this can add up. And I'm just going to grab the color here that we want, and it's text green 500. This is also a good example of maybe I want to create like my own CSS class for like complete or not complete if I start to add more and more styles and just like use the Tailwind styles inside that. So if I change the color and stuff, I don't have to constantly change these tests as well. And let's make sure these work. And then I think this is probably a good stopping point because I've ran a bit long. So we can see now that this is indeed working. We grab the H4. We can check that the complete message is rendered and that it's in the right color. And let me just pause here and see if folks have any questions or stuff that you're curious about, because I feel like I've been coding for a minute here. And how are we feeling about Cypress? Are we feeling a little more comfortable with this syntax and with working with it? Okay. Awesome. Are do you folks want to go? I bet in 5 minutes we can probably get like adding a task, writing a test for that. I know I'm running a bit long. Do we want to take 5 more minutes and just finish that one off, or you guys feeling pretty good about stuff?
I'd like to see it.
All right, let's take it. We'll knock this out in 5 minutes. The great news is it's wonderfully easy. And in fact, let's just go ahead and let's pull up those Cypress docs. From those core concepts from interacting with elements. And we're going to use click, and we're going to use type, and we're going to use check. So let's go ahead and code this up, and I'm going to give myself a little more screen real estate here. So we're going to have task interaction. We're going to have a before each. That's going to visit our homepage. And let's add a task. So we're going to have to do side dot get input. For the moment, I'm just going to trust that there's only one input here. So we're just going to do get input first. And then we're going to, I believe we want to do click and then type. Let's see, actually, though I might be making a bad assumption here, like I did with children. And indeed, we don't even need to click. We can just use type. And I probably don't even need first here. So let's just do type. And let's add feed the dog. And let's in fact just pull up Cypress. Site type can only be run on a single element, so I do indeed need this first attribute. And one moment, Carlos. Let's see here. And we can see here, this is pretty cool. We visit the page, we get the first input element, and then we type. Carlos, yes, sir.
No, sorry, it's you already got it. It was because the get returns an array.
Oh, yep. Yep, totally. Yep, that was my bad. So we fed the dog. So now let's get our button. And the input field and the button are good things that we could add IDs to because those are probably unique in terms of our user interface, but I'm not going to worry about that right now. And we're going to click on the button. And lo and behold, we have created a feed the dog task. So this is awesome. We've created the task. Now let's confirm it exists. And so this is where the fact that we have this code that already, though it's looking at a default task, it doesn't matter because the exact same JavaScript code is used to render a message and render the task completion status, if the message is green or red and the contents. It's the same code whether the task is coming from this default list here or one that we added. So because I've written these tests, the term is code coverage. We have that code covered. So really, and in fact, same with the task name. We have that code covered as well. Though it might be good to check the task name because maybe I did something wrong grabbing it from the input field. So I think all we need to check is it exists and has the correct name. Well, and is last in the list. So we're actually going to be confirming a couple different things here. And again, I'm going to copy my code here. And I should check the completion status as well, now that I think about it. I didn't check the checkbox status. That would be a good thing to check as well, but I'm not going to worry about that right now. So let's get our last task. Let's get an H4. Let's make sure it has task name. And this task is not complete, so it should look like this. And indeed, we see that if we get the last element, it has the correct text. So this is how, if you're thoughtful and you really break your functionality up into little chunks, it makes writing future tests easier and easier. So now let's try, sorry for all the refreshing there. Let's try checking the checkbox of our first task and seeing if it changes the completion status. And then I think that's going to be a good stopping point. And do folks have any questions before I build out this test? Okay, let's do it. So I'll add as a to-do, write a test to test changing task status from complete to incomplete because it's good to check both ways, but I'm not going to worry about that right now. So again, we just do sci.get div.task. And let's grab the first. And inside there, let's grab let me make sure I do this right. I'm not a wizard at this sort of selection syntax. As you can tell, there's a lot of sort of magic buried in here. And in fact, I'm probably going to need this to be double quotes. So I can put single quotes inside there, I think. Is this going to work? I guess actually that does work. I'm used to it working the other way. And now let's check it. And let's just run this and make sure that this works. And indeed, we see that this first one is now checked, which is awesome. And now we can add in should contain text is complete, right? Because we've already tested, well, we should really check for the color as well. So we might as well check for the color. So I'm going to grab that code right here. And we're going to put that here. And if we look in Cypress, let's see, we had a timeout. We expected input to complaint show is completed. But the text was, so this may be a typo in my code. Let's see what we have here.
Did it say that you were looking inside the checkbox to look for the
Oh,
text?
yeah, excellent point.
Also, you kind of just have a hanging square bracket in the find function.
Oh, thank you. Yeah, that should be closed out. I'm a little surprised that that worked. So let's do this. I think this will work if I just grab it once and I do task.find and check. And then if I do, we'll leave that there for a second. Let's just see if this works. So that, let's see if this assertion works. Oh, I apologize, guys. Let's see here. Expected input to complain text is completed.
I think it's still
Yeah,
has to give.
yeah. It's probably, this is a pass by reference, pass by value issue. I bet with this task object, I bet dot find is doing something to this object. And thus when we get here, it's still a checkbox. So I kind of half thought this might not work. And this is a good example of why sometimes with tests, like the way that seems like less efficient is better. If we just do this, fingers crossed, this should work. Yeah, so that works. That was almost definitely a pass by reference issue. A great example of pass by reference showing up in the real world. And let's see what this does not like here. Oh, because the have class, I need to get the H4. So this is a good example too of how brittle these tests can be and how sometimes less is more, or you end up writing helper functions in the tests to do this stuff for you to cut down on duplicate logic. But we can see here now, we get the task, we find the checkbox, we check it, we get the task, We find the H4 with the text, and we assert that it has what we would expect for a complete message instead of an incomplete one. And if I wanted to be really thorough, I could even um, like assert up here. And this is actually not a bad idea because this makes the test more robust. Confirm task is incomplete at beginning of test. And we change this just from green to red. And now if we run this, we see this works. And in fact, that's a massive improvement to this test because now I've confirmed I have an incomplete task that I've checked and which has now become complete. So if you guys remember at the beginning of the lecture, we talked about tests taking a lot of time and effort, but having a lot of value. And I think we've seen a great example of that because we've seen it's not a small amount of work to check, what seems like relatively simple behaviors. And in fact, even simple user interfaces have a lot of complexity. But now if I change something and it breaks, my tests will tell me with rock solid certainty. And if we're working for Amazon and they're $1.3 million a minute money machine of a website, now we can give them, the software engineering to like guarantee that our work is good to go. So I realize I ran long here, so I really appreciate you all sticking around. I hope this was useful. Um, the assignments for today are pretty open-ended. It's really just about refactoring some existing assignments. Let me show you guys. Actually, before we get into assignments, do folks have any questions that we can kind of wrap up on? Okay. This is a pretty good example of what you'll see on the assessment. Again, you won't be writing these tests, but you will need to be able to read these tests because it might tell you that an H4 element needs to have a certain class on it, for example. All right, so in terms of assignments, what we have for today is, again, please do make sure you're doing the reading. We would like you to just get your hands on Cypress. I recommend maybe like React Hangman or one of the more complex projects. Like add Cypress to it, write a couple simple tests. And then we also would like you to pick an assignment that you've worked on and do some refactoring. Um, Maybe go back to one of the very first ones or one of the earlier ones and work on improving the way the code works. Maybe you can refactor it to maybe break it up into some different components, reduce some repeated code, add some styles, and add a little bit of tests. And the context here is reading code is its own skill. And as software engineers, most of the time we're modifying existing code. We're not doing something greenfield and building it totally from scratch. And you'll discover, even for a small application, like maybe one of the ones from a couple days ago, it's a surprising amount of work and mental effort to kind of reorient yourself to it and dive in and modify it. I'm also working on a React assignment that's a bit bigger in scope. If people want to have stuff to do sort of reps and sets on with use effect and use state, and I should be able to get that out by the end of the day today if anyone wants that. Let me go ahead and stop the recording and open up our breakout rooms.